Have you ever looked at your phone, your computer, or even your smartwatch and wondered, how can something so powerful start from something as simple as sand? Well, today we're opening the doors to one of the most secretive places on Earth, a microchip factory where ordinary desert sand is transformed into the tiny brain that runs your entire digital world. Get ready because what you're about to see feels nothing less than magic. Welcome to Factory Fortune. Our journey starts in an unexpected place, not in a high-tech lab, but in nature. Microchips begin with silica sand, the same type found in deserts and beaches. But factories don't use just any sand. They use sand that is 99% pure quartz. This sand is heated to almost 2,000 degrees Celsius until it melts into liquid glass. From this glowing lava, something remarkable is born: ultra-pure silicon. This is the foundation of every chip, from the cheapest calculator to the fastest supercomputer on the planet. Now the real magic begins. The molten silicon is placed inside a powerful machine called the Czochralski puller. Here a tiny seed crystal is dipped into the melt and very slowly pulled upward. As it rises, the silicon begins to solidify around it, forming a flawless, shining cylinder called a silicon ingot. Each ingot can be more than a meter long and worth tens of thousands of dollars. And this entire crystal is grown in total darkness, silence, and precise temperature control. Because even a tiny vibration can ruin the structure. Once the giant crystal is ready, it's sliced using industrial diamond blades. Not once, but into hundreds of ultra-thin slices, each thinner than a credit card. These slices are called wafers. The wafer's surface is polished until it reflects like a mirror. Not a single scratch is allowed, because the next steps happen at a microscopic scale. One scratch could destroy millions of dollars of chips. Now the wafer enters a place more sterile than any hospital: the clean room. Workers wear full-body suits because even a single dust particle can ruin a chip. In this room, the real artwork begins. A powerful machine shines ultraviolet light on the wafer through a stencil-like mask. This process, called photolithography, prints tiny circuit patterns on the silicon. How tiny? The lines are thousands of times thinner than a human hair. The wafer goes through this process dozens of times, building layers upon layers, like constructing a skyscraper made of electricity. After the pattern is printed, lasers and chemicals carve the design into the silicon. Other machines add special atoms that change how electricity flows. These are the transistors, the tiny switches that turn signals on and off billions of times per second. Then come the metal layers, microscopic highways made of copper or aluminum. These pathways connect millions, even billions of transistors, so they can talk to each other at the speed of light. By the time all layers are complete, the wafer isn't just a piece of silicon anymore. It's a fully functional microprocessor city. The finished wafer is now cut into small squares, each one a separate microchip, but not all chips survive. Every chip is tested at lightning speed. The good ones move forward. The weak ones are thrown away instantly. A single high-end wafer can hold hundreds of premium chips, each worth hundreds of dollars. Now the chip gets its protective casing, Tiny golden wires connect the chip to the metal contacts on its package. The chip is sealed to keep it safe from dust, moisture, and heat. This tiny package is what you eventually see inside your laptop or smartphone. And just like that, the journey is complete. From ordinary sand to molten silicon to impossibly thin circuits to the digital brain that controls the modern world. Every message you send, every photo you take, every video you watch, it all starts with sand. This is the incredible secret factory process of turning nature into technology. If you enjoy interesting factory content, don't forget to subscribe.